What if you could have the superpower to see our world in a completely new way? Well, that's pretty much what happens when you combine drones, or unmanned aerial vehicles, with advanced geographic information systems. This duo is a total game changer, and we're about to see exactly how.
You know, for all of human history, we've designed our world from a ground-level perspective. But that whole paradigm, it's shifting. We're moving from looking up from the ground to looking down from the sky.
So, what are the two key pieces of tech making this all happen? First up, the UAV, or Unmanned Aerial Vehicle, what we all just call a drone. And second, GIS, a Geographic Information System. Think of it like the ultimate smart map. It's a system for capturing data that's tied to specific locations on Earth. You put them together, and wow, the result is revolutionary. To really get a grip on the impact here, we're going to explore this technology at 3 different scales. So let's start with the biggest picture possible, mapping entire cities. This is the macro view.
To see this scale in action, just look at this. This is a fixed-wing drone. This thing is the workhorse you use when you need to survey huge areas. It's part of India's really ambitious en route program, which is mapping hundreds of towns to guide their future development.
So the goal here is pretty huge. Replace old, probably inaccurate maps with a high-resolution, geo-referenced master plan. That means every single pixel on the map is tied to a precise GPS coordinate. We're talking a spatial resolution of 5 to 10 centimeters that's detailed enough to create incredible 3D models for planners. And here's a cool thing. Unlike satellites, these drones fly below the clouds so they can grab data pretty much any time.
Okay, from that massive citywide picture, let's zoom in a bit to the next level, the neighborhood. This is the meso view, and it's where this technology starts to get really personal.
You know, one of the most powerful applications here is monitoring change over time. Look at this. We're seeing a neighborhood in Andhra Pradesh, India. The image on the left was taken on September 15th, the one on the right just 6 weeks later. Officials can spot, instantly, which buildings are progressing and, maybe more importantly, identify any construction that wasn't approved.
I mean, this represents a massive leap in efficiency. The old way of doing things? You had inspectors with tape measures, a slow, expensive, and frankly, often inaccurate process. The new way? Wham! Automated drone surveys that give you fast, precise, and efficient compliance checks. It totally transforms the speed of governance.
But you might be asking, how accurate is it really? Well, check out this data. It compares the building's setback measurements from an approved paper plan to the actual measurements from the drone imagery. The numbers are incredibly close. This proves the method isn't just faster, it's reliably precise.
And this right here, this is the final product for a city official. All that complex data gets distilled into this super user-friendly web-based tool. An inspector can just pull up a 3D model of a building, spin it around, take precise measurements, and check if it's compliant, all without ever leaving their desk. I mean, that's e-governance in action.
Okay, time for our final zoom. We've gone from the city to the neighborhood, and now we're going all the way down to the micro view, finding every single tiny flaw on the surface of a building.
Now, for this kind of super detailed work, you need a different tool. Not that big fixed-wing drone, but a nimble little quadcopter like this one. It can get right up close to structures, hover, and capture the ultra-high-resolution images you need for structural analysis.
And the problem it solves is a big one. Think about traditional structural inspection. You know, looking for cracks in bridges, dams, or buildings. It's slow, it costs a ton of money, and let's be honest, it can be incredibly dangerous, putting inspectors in some really risky situations. So how does this automated system even work? Well, it's basically a 3-step process. First, the drone flies a pre-planned route, methodically snapping pictures of the structure's surface. Next, some really powerful algorithms analyze those images, automatically detecting things that look like cracks. And finally, each potential flaw is geolocated and mapped onto a GIS platform for an engineer to review. This is so cool. It's like a peek at what the algorithm actually sees. It takes the raw image from the drone, corrects for lighting, and then isolates what looks like a crack. After enhancing the image, it presents a clean, identified flaw for an engineer to take a look at.
And the results? They're just staggering. Get this, the system's algorithms achieved a 99.4% classification accuracy for identifying significant structural cracks. That's a level of precision that is, well, it's difficult if not impossible to achieve consistently with the human eye alone. No way!
Okay, so let's zoom back out and put all of this together. From the city to the neighborhood, right down to a single crack, what does this new perspective really mean for us?
It really boils down to 4 huge advantages. Speed. What used to take weeks or months now takes a matter of hours. Cost. It's vastly cheaper than chartering a plane or sending out whole teams of inspectors. Detail. We're capturing reality with centimeter-level accuracy. And, maybe most importantly, safety. We're taking people out of harm's way.
You know, I think GIS expert Devin Humphrey summed it up perfectly. He said, UAVs offer the unique ability for users to capture their own data on their own timeframe. The crucial word there is empowerment. It's all about giving planners, engineers, and even farmers direct control over the information they need to do their jobs better.
This all leads to the ultimate question, doesn't it? We now have this incredible power to see our world in searchable, analyzable detail. The challenge is no longer about what we can do, but what we'll choose to do first.
This technology transforms our world from a physical space into a rich, queryable data set. What you're looking at is a stunning 300-point cloud, millions of individual data points that digitally recreate this coastal community. Every building, every tree, every inch of coastline is now information we can use to build a smarter, safer future. The sky is no longer the limit, it's the new starting point.